Hi, we're going to finish up Focus 11, and I'm going to plug in the camera. Okay, I'm just going to talk briefly about these last two topics. The topic on electronic spectroscopy has a lot of familiar concepts in it from 107 for sure, and 250, 251 if you took those two classes. So when we're talking about molecular electronic spectroscopy, it'll be a little more complicated than atomic in that you can excite rotations and vibrations as well as exciting the electronic states. So the topic reminds us that electronic transitions take a lot of energy. They're usually in the colored region, the visible colored region, so ultraviolet and visible spectrum. So the electronic transitions are usually those that cause the color for a compound. So I want you to read this. You'll read section or topic D very carefully because it'll look very familiar. I'm not going to talk about most of it. It's talking about things like the vibrational states being excited, and so you won't have one band at an electronic transition. You often have several based on what vibrational transition corresponded or accompanied the electronic transition. The other thing it reminds you of is that when something's red, that's because it's absorbing the complement, the green, for example, here. Or if it's red, it could be absorbing all of the other colors. So the important thing is the color of a compound is related to the wavelength that it doesn't absorb. There's a section on what vibrational transitions are most likely to take place. And so the Frank-Condon principle is easy to understand when you read that. It basically says you go from the most populated state in the ground state, the most populated vibrational state. So if you start in V equals 0 because you're at room temperature, you'll go to something that's right above that. So right above that simply means you'd make an electronic transition without changing where the nuclei are. So you go straight up. That would be easy to understand. Types of transitions, whether you're going from pi to pi star or from a non-bonding to a bonding orbital, all of those things will impact the color, and then it will also impact whether or not the bonds get weaker or stronger. You can use electronic spectroscopy to measure ionization energies. They'll discuss that in the photoelectron spectroscopy section. You can analyze the concentration of a mixture, and you've definitely done that in Gen Chem, probably both 107, 108. If you've taken analytical, you've done a lot of that. So this just goes through looking at how you analyze a mixture and how you could get the concentration of each of the compounds based on the absorbance. A little bit about how you measure the speed of a electron leaving a molecule with the photoelectron spectroscopy. And that is all for that section. So read 11D really carefully. You should be able to understand all of it, but we'll have plenty of time in class to ask questions. The decay of excited states, you don't have to read that. We're going to have some lab projects that you'll get to choose from, and one group will do one on fluorescence. And so they'll teach you about the decay of excited states and do a lab that will help you understand it better. So that will be part of our lab project section. So as of right now, that wouldn't be on a test for you.